Here's my current progress on the integration project. So last week I connected the stepper motor, and I had that connected to this measuring a distance. So I've now connected this device here and also 3 LEDs. And so those are being controlled by the GPIO pins here. And so what's going to happen is it's going to measure the distance away from something, and depending on the distance it's going to calculate that between time intervals, and depending on the quickness of the movement that it measures, it will turn on different lights. And so there are different there's a different number of attempts that can be made before it cancels, and so this light will be on up to 50%, and then this light will be on between 50 and 80%, and then the red light will come on from 80 to 100%, and then it will flash and the stepper motor will do a full revolution, and then it will restart again. This all depends on how many errors you allow for. And so my overall plan for this right now is to measure some distance from something and take these outputs that I have linked to the lights and connect them into this here. Use them as the inputs, as you can see, and then yeah. So I will show my current progress. There's my code, and so what it's going to display is my current counter. So the counter is the number of errors you allow. So if I put in a number like 5, it will count up to 5 and then it'll exit. For the example, I'll do 2 or 3. It will show high and low because that's triggering the ultrasonic sensor. This is from some prior code we've used. My start time and my end time, and then it calculates the distance based off of this. And then here you'll see it measures the speed. So here we've got it marked too fast, and here is speed okay. So that means the velocity between time intervals has not been too much. So the calculation isn't showing, but that is going to be measured as a change of 1 centimeter or 10 centimeters, sorry, between time intervals. And then my calculator, my counter will go up, and then you'll see LED here, and that is sequencing the next LED position. And so if I were to do a number like 10 errors, 50% for the blue light would be up until 5, and then it would be a yellow light coming from this LED sequence, which would be up until 80%, and then the red light. So I'll run this function and we'll see. So the number of failures that are accepted, do 3 failures. So you'll see it's measuring the distance, and so one of the movements has been too great. Another one has been too great. And I'm just moving it back and forth, and then you'll see it is reset there. So I'll start again. So it's measuring. There, it's steady. Now I'm going to move it. You'll see it cancels. Then I'll move it again. You'll see it exits. So I'll try to show this with it. And you can see when I move it, the counter will go up. Currently it's measuring an invalid range. Oh, I didn't have it right on it. Okay, so what I've done now is I've connected the ADDA module here. And what I'm going to be using it for is using the photoresistor here and measuring, sending pulse width modulations to this LED and measuring the change in voltage because of the resistance change on the photoresistor when this is lit up in various stages. I've also started working on a program which I think will function as the overall method for this project. It's going to measure the proximity to something. So my hand, say it's here. If it were to move forward a centimeter, it will then take a centimeter in steps. It will also be calculating how quickly it takes that change. So it's going to be taking measurements every 2 seconds. And so what it will do is when it takes a measurement here and then another measurement maybe 6 centimeters in front of that, it knows that that's over 2 seconds. So it will calculate the velocity per second. So that'll be, 3 centimeters per second. And it has a certain range. And if it exceeds that range of the maximum velocity, it will get a warning. And so what the warning will do is it will set this LED into a higher state. And then as that goes on, the user is able to select the number of failures you're allowed, so the number of 2 quick movements you're allowed. At the end of that number, this will make a rotation, and then it will reset and begin measuring once again. The last thing I'm working on for my project is going to be fully integrating this system with the connection I have between the ultrasonic and the stepper. So I'll be integrating that as well as just finishing up some multi-threading to make sure that everything can work simultaneously.